Peace in, peeps. We're in grade 4, part 2 of the hardest math problems. Show you work. Yeah! All right. So I'm going to jump right in this time. There's a few extra questions. Theoretically, they're shorter in length to solve, but just in case I can all fit it in within an hour, I'm going to try to do that. Otherwise, I'm going to split in two parts about halfway through it. We'll figure that out halfway through it. All right, so let's get to it. All right, so this is we're going to take this a sentence at a time. There's no illustration. Let me move this out of the way. So the area of a rectangular doghouse floor is 15 square feet. So we're going to draw it. So it's telling us that the whole area here, this area, is equal to 15 square feet. We're at this point right here and right now as well. Let me just make sure this is showing on you guys' screen properly. Yeah, we seem good with that. Okay, so that's the first mistake a lot of kids do. They get confused about the area, the difference between area and perimeter, and it kind of gets a little messy. All right, so the area of a rectangle is equal to the length times the width. Normally the longest side is called the length. So this is traditionally called the length, and normally the shortest side is called the width. So it means that if we do this length times width, something times something is equal to 15 square feet. And I keep showing you can do FT that, you can do SQ, FT like that, or you can actually write out the words square feet. Okay? So they're telling us that the area is that. The length of the floor is 5 feet. So they're telling us this is 5. Okay? What is the perimeter? So perimeter you consider like a fence. The perimeter of a rectangle is going to be its length plus its width. Right? So what we're going to do is, let me change the colors for 1 second. We're going to traverse the length. We're going to traverse the width, right? So that's these two here. And then we're going to traverse the length again and the width again. So we're going to add that in as well. Okay, and there's a couple ways to do this. You could also write this as L plus L plus W plus W. Or you can observe it and see that's 2L plus 2W. And for those of you who know your distributive property, which is A times B plus C equals AB plus AC, which also works in reverse, we can see the reverse is what we have here. So this becomes 2 times L plus W. So we can use all of these to compute the perimeter. They're all valid ways to do it, especially since we have the 5 here. Okay, so what it really means is, if we look at this more conceptually, that if that L is 5, then this L is equal to 5. So that means we already have the 2 L's. We have the L plus L is going to be equal to 10, right? All right, so now the question is, what is the W plus the W over here being equal to? Well, we already know the area is the length times the width. So if we know that the length is 5, so we're bouncing back before to the concepts. We can do the 15 is the total area divided by the length. Okay, because we can use the formula here. If the area equals the length times the width, then that means the width is equal to the area over the length. Okay, so that's where we get the 15 over the length. And we know that 15 over the length is 5. So 3. So the width is 3. Okay, now that we know the width, we can do the width plus the width over here and get 6. And when we add them together, we get 16, right? And that also works if we come over here and say, use this last choice. If it's 5 plus 3 parens times 2, get 2 times 8. That's also equal to 16. Okay, and we can use any of the forms that I gave you here as well. right? Because 5 plus 3 plus 5 plus 3 is also 16, right? And the 2L plus the 2W is basically what I did right there, all right? So the perimeter is going to be equal to 16 feet. It's not square feet, it's feet, right? This, if you imagine the perimeter as if it was a string, you just made a big string around the whole thing, or a fence. So it's basically, the perimeter is asking, what is the length of the fence that you would have to put around here if you were going to do that, okay? Whereas the area is 2 dimensions. The area goes this dimension and that dimension, okay? You could argue the perimeter goes around all of them. Yeah, but you can unravel it as a string. So that's the difference, okay? You can't really unravel the area, okay? We can get equivalent areas, right? But that's a different story, because you still need a unit. If you did that, you would still need to find what you see these, and sometimes they might say that's 1 square foot. Okay, well then you still have to define that, right? Because we can have an equivalent one, which is 1 square foot. We had 1 square foot there and 15 for the length of here. Okay, with a whole bunch of square units in there. Okay, these would be equivalent areas, but they're different things. By the perimeter to this, if that's 15, then that's 15. If this is 1, this is 1. So the perimeter of this would be 32 feet. Okay, just to show what some of the examples are. Okay, so this is a multi-step word problem where you had to know what area meant, you had to know what perimeter meant, you had to know their formulas, right? It was also visual, because it's not just saying 2 plus 2. You have to, at some level, at least conceptually, if not physically, visualize what the rectangle looks like and what's going on exactly. Okay? And you have to be able to understand length and width and kind of things like that as well, all right? So this means that it delved into geometry as well, because it's dealing with a rectangle, right? And it means you need to know what an area is about, what a perimeter is about. You need to know your multiplication table and your division table, so it's dealing with arithmetic and operations as well. Okay? And if you have a problem memorizing area versus perimeter, one way to distinguish that is just memorize what one of them is. This way you don't get confused. I don't care which one you pick. If you know what perimeter is, just memorize that. And then area is not that. And if you memorize area, then perimeter is not that. That sounds like a silly / crass way to do that, but if it works, it works. But you should really understand what both of them are about, okay? Even if you can't remember the formulas. One is about the thing around something, right? The other is the inside of it, the contents of it, if you will. All right. There's also the concept of volume, but we're not going to get into that now. Volume deals with 3 dimensions, as if what's inside of, say, a cube or a sphere or something like that. But that's not what this question was asking. All right. So, with that in mind, the answer is not 15 plus 5 equals 20. That's not the answer. The answer is not 15 times 5 equals 75. That's not the answer. Okay? Because we have to stick with the perimeter and the other ones. Okay? Even some kids get this 3 over here, and then they'll still do something like 5 times 3 times 15 or something like that. That is still not the answer. Okay? And then they kind of half remember that perimeter has the 2 L's and the 2 W's, so they might even multiply this by 2. That is still not the answer. Okay? What else can we say here? Some kids know that the area is the length times the width, and they kind of forget what perimeter is. So what they do is they do L plus W, and they square it. So in this case, that would be 8 squared equals 64. That is not the answer as well. Okay, that's misapplying your rules and things like that. And some kids don't even know to get this far, and they might just do 5 squared and get 25. That is also not the answer. So there's lots of kind of meandering kind of weird stuff that can start happening with this. So just remember, it was a multi-step problem. You had to do the 15 divided by 5 to get the 3 first, and that gives you the width, and then they already gave you the length, so then you can apply the perimeter and get that out of it, okay? Let me just think if there's anything else to say about this problem. No, I don't know that there is. Okay, so that's what's going on with that. It's about your area and perimeter, basically, and just applying them properly and in the right context. Take a sentence at a time. Remember that you just can't get the 3, by the way. The 3 is not the answer. That's an interim temporary value, because once you get the 3, you still need to do the perimeter. So that's, you guys will lose credit. If we flip now that I'm talking about standardized tests or taking an exam or solving a homework or getting credit for it, you have to solve a problem in full. Remember, math is not just about memorizing formulas. It's about critical thinking. It's about splitting a problem up. And part of splitting the problem up is understanding what the problem is asking you to do, which also deals with reading comprehension. Okay? But you can't, part of your attention to detail is understanding the different steps that are required to produce the right answer. Okay? I get the text here. Okay. Okay, we also have a bunch of stuff here. So last month, a store sent 2014 emails to customers about sales. So we have emails. I don't know where this is going. We have 2014. The number of emails sent the month before, so I'm going to put MB maybe. So emails this month. Emails this month is 2014. The month before was 2104. Okay? Using the symbols, these symbols, which means less than, greater than, or equal to compare the two numbers. Which two numbers? This number and that number. To compare the two numbers of email sent. Explain. So this is, again, is a two-part. So first of all, they're asking you to use the symbol to do the comparison, and then 2, explain why. Okay? So this is the explanation that seems to kill a lot of kids, because that's more conceptual. The actual comparison is probably the easier part for most of you, and it's almost robotic. So this, at least from the question number 1 part, there's 2 answers that are valid. First of all, some kids say they're equal to. It's 2014 versus 2104. If you have dyslexia and so on, you have to work out strategies to get yourself set. I have it, and numbers flip on me sometimes. Words flip sometimes too, but it's mostly numbers, especially in a context like this. So you have to be real careful that you're really seeing the right numbers, including when you do something like copy them down like this. That the copying can kill you. Okay, so let's just set up the 2 numbers. We have 2014 compared to 2104. Okay, so I can do this. That's one answer. Or I could do this. And both of these are true. Okay, so you answer number 1 by doing that. Use the symbols to compare them. That's the comparison. Either this A form here or this B form here. Okay, now it says to explain. Okay, so one explanation is that the 2's of the place value of the 2 is that's not a 2. That's a 2000. So you're comparing 2000 here. Let me change the color back again. You're comparing 2000 here and 2000 here. Okay. If we now try to do something else, let me change the color one more time. So at that level, they're still equal. Now I have a 1 here. That's 100. 100, not just the 1, and versus 0. So 100 wins over 0 any day. So that's why we have the 2104 is greater than the 2014 in both cases. Or conversely, the 2014 is less than the 2104. Okay, so that's the rationale, that the place value of this here, the 100, is greater than no hundreds. Okay, we could have also actually done a subtraction as another kind of solution explanation. You put the larger number on top and a smaller number, right? If we went through the subtraction, we would get 90. So it means the first number here, if I made this A and B, A is 90 bigger than B. So we can prove it by actually doing the subtraction and getting that kind of arithmetic out of it. Okay? So this was really a place value question. It was also a two-part question. The other one we had two parts because we had to get an interim value and then use it. In this one, they're asking you to do two different things. And again, it's still about your attention to detail, ripping the problem apart properly, and not leaving the problem until you finish solving it. Okay? And these are kind of hard lessons to learn. So this also deals with magnitude, right? And max, min and max. Okay? Things like that. So this one was kind of simple enough, though. So it was dealing with arithmetic, your operations, comparison operations, and in the case if we went and did this, actually doing subtraction. Okay, but it's really dealing with place values. That's your clincher for this. Okay, this does have a visual. So the first is split into 6 parts, and 3 are shaded. So I don't know where they're going with this, but it looks like equal parts. So I'm guessing that 3 out of the 6 are shaded. I'll put that parenthesis here because I haven't read the word yet. The next one shows, it looks like equal parts as well, shows 0 out of 4 are shaded. Okay, again, I don't know where they're going with the problem, but that's my observation so far. By the way, also on the first one, 3 out of 6 are also unshaded. So if you did shaded and unshaded, okay, that's what we're grokking out of that. We don't know where they want to go with that. So let's go back to the words because we don't know. Mandy shaded the fraction strip to represent the fraction. So there you go. So we don't know which fraction she's representing it, either the shaded ones or the unshaded ones. Okay? But it says shaded. Okay, so it's the shaded one. So 3/6 of that is right. We also believe they're equal parts. Then it says shade the fraction strip below this one here now, so that it represents a fraction that is equivalent to Mandy's fraction strip. Well, if she got 3/6, we know that's equal to a half. So how do we get half of this? We can do this and this, and we get 2/4. And we know that's also a half. Okay? What I don't like with this problem is they didn't say they're equal parts. It just says she shaded the fraction strip. Okay? And then it asks for something equivalent. So it's a little broken in the question here, which I'm not really keen on 100% here because this comes from a New York State exam, and it could be the reason some kids couldn't solve it. Okay? So this is dealing with equivalent fractions and shaded areas as well. There was another solution to the second one here, and let me draw it out. Actually, there's a bunch of solutions, but we could have done here and here as well. Okay, we could have also done like that. Okay, and we could have also done, we're assuming these are all split into valid quarters. We could have shaded here and shaded here. Okay, and then finally, oops, assume that's the same kind of rectangle. I could have shaded the last box and the first box. Okay, those are all halves. That's a half shaded, that's a half shaded, that's a half shaded. Okay, and then there's another part. It still says explain. So the explanation is to illustrate that you knew the original thing was basically a half or 0.5. Okay, I'm going to put that in parentheses because that's not really the focus of grade 4, but if you happen to know that a half is still 0.5, you know a half of a dollar is half of a dollar. So you know 50 cents, right? 0.5 is half of a dollar. So it's not a totally foreign concept to fourth graders, that kind of a thing. And that's really what this is about. And it's exercising fractions is really what this question is about. It wasn't too deep, although a lot of kids are getting these wrong. That's why I'm going over each one of them. Okay, this kind of changes gears a lot compared to some of the other examples I did. So we have an illustration which shows ray A and B, right? An array starts at a point and extends out a line and goes into infinity, basically. And we can name the ray, right? By basically, there's a point right here too, that technically I'm not sure why they didn't dot in there, but in any event. So that's what I'm saying. It's AB or BA and BC or CB. They're both valid names. Okay, so we don't see anything else they're telling us here. So it says Jolie started with the angle ABC. So we follow that. A to B to C. Whoops. Let me get rid of that for a second. So they are talking about this angle right here. This is angle A, B, C. And they're telling you that it's equal to 132 degrees. As shown. So they're telling you it's 132 degrees. Okay? Jolie wants to cut the angle into two smaller angles. So she's going to do something like that. Okay? Draw unlabeled ray BD, so it starts at B. So we would have a ray like that. You have to draw it, and D might be there. Okay? To cut angle ABC into two small parts with DBC, so DBC is this angle right here. Okay? So I'm going to do that right there. That's what DBC would be. Being 55. Okay? What is the measure of angle ABD? Okay? Let me change my color one more time. Let's go with purple. So ABD is right here. You're done already? Huh? Really? All right, sorry guys, I'm talking to somebody here. Okay, that was ABD. So we need to know how much is that, okay? So there's probably kind of two ways to do that. One is, I believe in grade 4, they provide you a protractor, right? So that you can measure, you can confirm that it was 132 originally, and you can actually draw you can actually draw DBC to be 55, and then all you have to do is measure the purple part here. Okay, and they normally give you a little wiggle room because you may be off by 1 or 2 degrees. I think in New York the wiggle room is 5 degrees you can be off by. So if the angle was supposed to be 70 and you say 60, you're going to get wrong. If the angle was supposed to be 70 and you say 90, you might be wrong. If the angle was supposed to be 70, I believe they allow you from 66 to 74, something like that, give or take on either side of it. Okay, so you can get out your protractor, line it up here, line it up against one of the sides, this side or that side, and measure the angle on there. The other way is to actually do it mathematically, right? If you know the whole thing is 132, and you know one of the sub-angles was 55, right? Then all you have to do is subtract the two of those. No? So we're going to 2 minus 5, 5 minus 2, you can't do it. So you're going to borrow. You're going to get 12 there, 7. That was a 2. So we're going to borrow from here, get 12, and get a 7 again. Okay? So we get that the answer would be 77 over here. Okay? And that's our work. Okay? So let's go through this a sentence at a time again, just to make sure. Remember this thing with multiple questions and we're not always answering the questions? Let's just make sure we did everything. So she started at ABC and was 132. She wants to cut it, and then it says, draw and label. If you don't do this, you lose points. So I did that. That was right here. That was this green thing right here. Okay? I drew a ray and I labeled it. Okay? So if you don't do that, you're not going to get full credit. Okay? And then it says to cut ABC into the small angles, what is the measure? Okay? And that would be the answer here. Okay? That would be up here. And if you notice, they're giving us a hint that the answer is going to be in degrees. It's not terribly helpful here. So again, this dealt with geometry as well. It dealt with angles. It dealt with how angles accumulate and add up together. It deals with drawing and labeling, some geometry as well. And it deals with measuring if you end up using the protractor mechanism. But even if not, you measured it by doing the subtraction. It also in your brain is going to give you a sense of scale. Okay? And I do not believe in an example like this that if you drew ray BD incorrectly, so for instance, here was the original ABC. Okay, let's say you drew this here, and this was D. Let's say you drew it so it looked like a 90-degree angle, even though they're telling you it was 55. I don't think you're going to lose points for that. I'd have to double check the policies of how that exam works. But as long as you would have put the 55 and the 770 in there, and they're not even asking you to put it in there, but they're asking you to label this ray here. Okay? But if you make it semi-accurate, right, we know that if the purple line I just drew there was 90 degrees, then if I went halfway, let me change the color of this one more time. If I drew this about halfway, where that was 45 and this was 45, then we know the actual answer has to be about right there. About 10 more degrees more than the 45. Okay? So that's really where the BD was supposed to have been. Okay? About there. And again, if they provide a protractor, you should really be using the protractor to do it. All right? So again, this was really just testing your angle sense, if you will. Your angle proficiency, your angle no hesitation math, if you will. Right? Nothing super duper deep. But you have to know what a ray meant, and you have to know kind of how angles were put together. And it's important that when they say ray BD, this first letter is the starting point. Same as when they said angle ABC, you start from A, you go to B, and then you go to C. That's how you know what the angle is. Okay? And just as a slight sidebar discussion, there's actually two angles here. There's this angle here, and there's another angle here. So if you will, this is normally referred to as the inner angle. And this is normally referred to as the outer angle. Okay? So by the fact that they said this was 132, you were supposed to have known that it had to be this one. Because this one, if I drew a straight line coming out of here, this part right here, let me change the color one more time. We know that the measurement of a line is 180. So that meant this whole double green thing had to be bigger than 180. But they're saying it was 132. So for that reason, we know it has to only be the angle right here. Okay? So they didn't need to say inner or outer or give us any more qualification. As mathematicians, we're supposed to know what they were really asking us to do. So as you can see, this this involved a lot of knowledge and a lot of thinking, a lot of processing kind of intellectually to be able to get past it. Even though on the surface, this is not really a terribly hard question and deep problem. That said, most kids got it wrong. Okay? So be careful. Make sure you know what you're being asked. And again, I think a lot of kids got it wrong because it said to draw and label, and they didn't do that. So the perception that a lot of kids got it wrong might be misleading. Okay, 50 is strictly a word problem. A recipe uses 3/4 cup of sugar, 3/8. See, there's my dyslexia kicking in. For each, so to me, I set up a ratio. For each cup of flour. Okay, so I'm right there. So if a baker uses 10 cups of flour, so what I'm going to do is take that ratio and set up a proportion, which is comparing two ratios. 10 cups of flour. What is the total amount of sugar? So we're going to get X cups of sugar. So there's a few ways to do this. We can see that this is times 10. So all we have to do here is 3/8 times 10. And any number is itself over 1. So this is really 38. Okay? And we're going to avoid the simplification for a moment. The other way to do it is to do this as a cross product. When we comparison the two ratios as a proportion, we can resolve the unknown by doing the cross product. So we're going to do that. We're going to get 3/8 times 10 equals, and then do that one. 1 times X, or just X. And we end up with the same thing. We end up with 38 equals X. Whoops. Okay. And technically that's acceptable. In a lot of things you're being asked to simplify. So 38 equals something and something 8. So we get 8 is 8, that's too much, times 2 is 16, times 3 is 24, times 4 is 32. So we have 3. We get 24, right? And we have 6 left over. And again, if we continue the simplification with the mixed number, we get 3 3/4. And if you want, again, depending on where the problem is kind of going, that's equal to 3.75. Okay? Again, that's not really a requirement of grade 4. And then our answer should be in cups. Does that make sense? Is that what we solved? Yeah, we're looking for cups. We got cups of sugar. Okay? And then plug your number back in. Try to make sense out of it. Well, if you got 10,000 or if you got 0 or something, you have to apply your capabilities of estimation and so on. All right? Just to try to kind of figure it out. Because if you look at this, 3/8 is about a half. And if there were 10 of them, it's about 5 then. 10 times a half is about 5. And that's what our answer was. If we were to estimate it. So if we round this up to the next 5, it would be 5. Okay? So that's the problem with estimation. Estimation doesn't mean getting exact. It just means getting a ballpark number. So if you estimated a zillion and you got 3, something's wrong. Something's either wrong with the estimation or your actual calculation. So this problem dealt with fractions. This problem dealt with a ratio. This problem dealt with a proportion. This problem dealt with multiplication. This problem dealt with converting a top-heavy fraction. And this here is a top-heavy fraction. And by that I mean the numerator, the top number, is larger than the denominator. So, and then it also dealt with mixed numbers. It dealt with simplification, right? So there's a lot going on in this, quote, trivial kind of problem. Right? We could have also done stuff like 3/8. If 3/8 was 1, then we could have done that 10 times. So I'm just going to put ... here, plus 3/8. And if we counted the 3/8 10 times, we still would have got to 38. Okay? We could have also counted up that if we start from 3/8, The next number is 6/8. The next number is 9/8. Right? Dot, dot, dot. We would still get up to 38. Okay, so we can do repeated addition or counting up as well. Know your multiplication table, because in many cases doing the count up is not really going to buy you too much. This was not a division problem. We didn't have to take 10 divided by 3/8 or anything like that. That is not the solution to this. This was also not 3/8 plus 10. That's also not the solution to this. It was also just not 10/8, and it was not 10 over 3/8. So there's a whole bunch of answers here that it wasn't. So be careful with this. Always take a sentence at a time. Always know what you're being asked to do, and make sense of it, right? And by the way, that's one of the things about this here, the count up conversion. You can see this number increasing. It's going up about 3 each time. Oh, it's going up 3 each time 10 times. Oh, it went up 30, right? It went up to 30, right? That should bing, bam, boom, pop into your head. Because if you read the words and you're stuck, just start small and try to start making sense of things. And try it with 1. If you can't figure it out for 10, what if it was just 1 cup? Oh, with 1 cup, it would be 3/8. Okay, what if it was 2 cups? If it was 2 cups, it would be 3/8. Oh, plus another 3/8. Oh man, that's 6/8. Oh, that's 3 times 2, right? So you can start producing the formula by experimentation, just by having your math sense to you. All right. So that's part of what's going on there. So I mentioned before, it's about fractions, simplification, mixed numbers, repeated addition, ratios, proportions, multiplication table, the whole shebang. Yeah. Okay. Okay. Then they're going to ask you between which 2 numbers. So the answer here was 3 3/4. Whoops. Here, let me get rid of that for a second. Between what 2 whole numbers does your answer lie? Okay, so now it's kind of dealing with a number line, if you will. So if I was kind of split this up, if this was 1, this was 10, this is 5. So we know we're in the first part. So I'm going to try to split this up into 5 pieces. We're going to get about 1, 2, 3, 4, 5, right? So 2, 3, 4, 5. Okay, let me make that 6. Forget this part for now. It's not the scale then. So it's saying it's 3 3/4. So 3 1/2 is about right here, and 3 3/4 would be right there. Okay, so that's my 3 3/4. So now it's asking us, do you know what a whole number is? Well, it turns out that 3 is a whole number and 4 is a whole number. So they're really looking for between three and 4, not 3 plus 4. 3 and 4 would be your answer there. Okay? And there's a nuance again to this question, because it also turns out it's between 2 and 4 as well. I'm just going to put in. It's also between 2 and 4. But if it's between 2 and 4, it's also between 2 and 5. And if it's between 2 and 5, isn't it between 1 and 6 too? In fact, isn't it between minus infinity to plus infinity? Which is pretty weird when you think about it. Right? In other words, it's a number line and it's just a point in the number line. So it's a weird question, but really they're looking for between 3 and 4. Okay? That's the preferred answer here. So this dealt with indirectly the number line. It wasn't really a number line question, but we could use that tool and that concept and that way to visualize it as the solution mechanism to this. All right. So be careful. And there's another term for this. Between it could normally be, instead of that, it would say between which consecutive integers. So that means immediately following each other. So if they did that, the only answer would be 3 and 4 then, because they're whole numbers. It's not talking about fractions, decimals, rational, irrational. It's talking about just whole numbers on your number line. All right? Yeah. So there we go. Okay, 51. There's a triangle floating in space. Is the triangle? There's nothing else we can grok out of it. We don't have a clue where they might be going with this. Is the triangle described as right, acute, or obtuse? Well, a right triangle must have a right angle. So if I label this A and this double 1B and this triple 1C, okay, to me, by I don't see that A, B, or C are right angles. So me personally, I would rule that out. Now I know acute means less than 90. Okay, and I know obtuse means greater than 90. Okay, so it seems to me A is smaller than 90, it seems to me B is smaller than 90, and it seems to me C is smaller than 90. Hey bro, that's actually what an obtuse triangle is. Okay, explain how you know the answer is correct. All the angles are less than 90. All right, that's it. It's not deep. If they provided a protractor, you could actually measure to confirm that they're all less than 90. This is about terms, it's about geometry, it's about triangles. It's about knowing right triangle, acute triangle, obtuse triangle, right? Just to draw an obtuse triangle, that might be one of them. So even though this angle and this angle, even though the single and double ticked are acute angles, and this triple one is obtuse, that's what an obtuse triangle is. Okay? I'm just giving you extra stuff here so you know what's going on. So there's acute angles, right angles, and obtuse angles. And there's also right triangles, acute triangles, obtuse triangles. So each one has an angle definition and a triangle definition that gets associated with it. Okay? And in terms of a right triangle, if that's 90, then we're going to have two other angles here. And if I call them A and B, okay, since the sum of the degrees in a triangle, so A plus B is going to be equal to 180. A plus B is going to be equal to 90. Okay? So if they're equal to 90, they can never be obtuse. One of them could never be obtuse, because then that one angle will be greater than 90. So a right angle can't be obtuse as well. Ta-da! See how things work out mathematically? Okay, we're up to 52, and I'm 43 minutes. 52, what do we have? 53 is one more. 54 is another. 55. What was that? 3? 1, 2. 3. 4. Okay, this is what I'm going to do. I'm going to end the stream and start another one up immediately right after it. So I'll be right back.